postdoctoral research in astrophysics at PUC.
And I'm Franz Bauer, professor at PUC. We studied, essentially we were looking for very high redshift massive black holes in order to understand how they form. And so we used a selection method in the optical to select very distant objects that were forming in the early universe. And we ended up finding this particular guy, which looks very red because it lies at a very high distance. And so we're able to quantify it or classify it as a supermassive black hole with a mass of around 10 to the 9 solar masses, so about 1 billion times the mass of the sun. And what was interesting about this is that we then followed it up with X-ray observations, and were able to detect it. And in particular, we were able to detect not very many photons, just a few photons, but those few photons tell us that the object was very highly obscured. And this is interesting because it's the first object at such an early time in the universe where we see this obscuration. Most of the other objects found in this era are all unobscured objects that we think have already gone through the process of building up.
So another interesting property of this object is that it's not an isolated quasar. It's not just alone in the space, but it actually interacted, is merging with another galaxy, which is close here. And we actually don't know if the X-ray emission comes from the quasar itself of the companion galaxy, which is merging. In the second case, it would be very, very interesting because it would be the first quasar pair we know in the high-redshift universe. One of these quasars should be obscure.
One of the formation mechanisms is for these black holes to grow so large is by merging with other galaxies, and so we may have actually caught this particular quasar in the act of merging, which is why it's so exciting. And it's right now theoretically a little bit difficult to understand how we can grow massive black holes to something like 1 billion solar masses in such a short amount of time. These quasars existed at roughly around 1 billion years after the universe formed, and we think they've only had maybe 500 million years, 500 million years of time to grow. And so building up from a very, very tiny seed black hole, this is very difficult. And so this may suggest that these seeds actually formed in a much larger mass initially in these early proto-galaxies.
So this quasar was first selected in Pan-STAR, which is an optical near-infrared survey, which is this image. And then it was observed also with Hubble Space Telescope in near-infrared and with ALMA in some millimeter band like this. Our contribution was to observe this object in X-rays using Chandra, which is a NASA satellite. And these are the X-ray images in two different energy bands, soft energies, so low energies, and hard energies, so high energies. And here you see that there is no emission in the soft energy, but there is a significant emission in the hard energies. And this property is a strong indication of a high level of obscuration in this quasar.
One of the most sort of critical aspects of the investigation is the use of very high resolution telescopes, in particular ALMA from the ground and also HST from space, where we're able to distinguish both the quasar and its companion. And having the spatial resolution to resolve this is very important. Otherwise, with the resolution of pan-STARRS, for instance, we wouldn't be able to see this. And critically, the resolution of Chandra is able to distinguish between these two positions and suggest that maybe the companion galaxy is the obscured AGN, obscured supermassive black hole.
The future of this work is to observe this object again with Chandra with a longer observation, in total 120,000 seconds with Chandra, in order to constrain better, so to identify better the position of the X-ray emission and to associate the X-ray emission with either the quasar or the companion galaxy, and also to constrain better the obscuration level. And also we got new observation in near-infrared with an instrument called a shooter at VLT here in Chile, in order to get a better UV spectrum of these quasars and to understand better the properties, the physical properties of this quasar.
this quasar is among something of the order of 100 objects that are known at this epoch. This is the first one to be obscured, or to show signs of obscuration, and it hints at a very large population that may have not been found before, that may have been difficult to find. And so understanding in particular the characteristics of this object can help us figure out where else to look for the rest of this population. We think that this population is critically important to grow these supermassive black holes to the sizes we see. And so a big question right now is where they all are, and something to look forward to in the future.
So this work was done in collaboration with other astrophysics researchers around the world, in the US, for instance, in China, and in Europe, and of course here in Chile.